Hello, my CS61 BFFs. I am so excited to walk through the introduction to homework 6 with you guys. We're going to talk about BSTs, binary search trees, and hashing today. So there are two main parts to this homework. First, we have the BSTStringSet. And so this one is asking you to implement a set of strings that are stored under the hood in a binary search tree. And there's a skeleton code provided, and you have to meet some runtime requirements. Then we have the ECHashStringSet. And so just like before, we're implementing another set of strings, but this time under the hood, they're stored in a hash set, not a binary search tree. We're going to have you use external chaining. That's what EC stands for. And there is no skeleton provided, but we're going to essentially walk through a skeleton in this video if you end up getting really stuck. You also have to meet some runtime requirements again. And so both of these classes are implementing the string set interface, which we've given you. And so this interface basically defines three methods that you have to support. The first one is put. And so put takes a string S and adds it to the string set. And if it's already in the set, it does nothing. Then we have contains, which returns true if and only if S is in the string set. Finally, we have this asList method, which returns a list of all members of the set in ascending order. Note that for the hash set, it actually doesn't require it to be in ascending order just because it would be a hassle. But for the binary search tree set, we are going to be enforcing this ascending order or sorted rule. So we can talk about BSTStringSet first. And you're actually provided with this private interclass node. Each node has a string, which is the item it holds, and a pointer to a left and a right child. And so, for example, if we go look, and actually I'm going to delete this because this was me writing this earlier. If we look at the BSTStringSet class, we'll notice that we have this private node class inside of it. And so you can use this node. This is basically the building blocks of your BST. And you can work with these left and right children to traverse the tree. And so this is the essentials of the binary search tree string set. Now let's take a look at what would happen for the contains method given these calls. If we said contains of by, we would eventually want to return true. And the way we would get there is we'd start at the root like always, and we would say alphabetically, by is less than cat, and things that are less than go to the left. So we'd go to cat.left. Once we're here, we'd compare by to boo, and we'd see we're greater than boo. And so we'd go to boo.right. Then we would compare by to by, and we'd realize, oh, we've found the element we were looking for, and let's return true. What if we called contains of city? Again, we'd start at the root, and we'd say alphabetically, city is greater than cat, so let's go to cat's right. City is less than Cobb, so let's go to Cobb's left. But then we realize, oh, it's null. So if city was present in the binary search tree, it must have been here, but it's not here. We have a null. We've reached the end. Therefore, contains of city should be false. What about the put method? Well, what would happen if we tried to call put of by? Same process. We'd say by is less than cat, by is greater than boo, by is equal to by. Oh, we found the element we're trying to put in. And so like we defined earlier, if we're trying to put an element in the string set and it's already there, we'll just do nothing. What if we tried to put city? We'd say city is greater than cat, city is less than Cobb, so we go left, and oh, there's a spot, there's an empty spot where we can put it, right? Nothing is here, and so this is where we should put city. And so it seems like at their core, put and contains are actually really similar, right? And so maybe you're thinking to yourself, it seems like I'm going to be writing pretty much the same logic for both of them. And so maybe instead of writing it twice, we could, be a little smart about it. Remember that you're always able to add private helper methods. And so this is one big tip, is that put and contains are really similar. And maybe there's some helper method that can take advantage of their similarities. Now, the asList method, which is the last method you have to implement, might seem a little daunting, right? Like, how do we go through this tree and get all the elements in sorted order? Well, if only we gave you some piece of code in the skeleton that would help you do this. It would be such a shame if you all were clever and looked through the skeleton and instead of rewriting the logic to create the sorted list, just used something that we gave you that can already do it. I will leave it to you to go through the skeleton and logic through how we can make this work. Now we're going to talk about ECHashStringSet. And so EC here stands for external chaining, right? And recall from lecture our overall design for a hash set with external chaining. Basically, we have some structure that contains buckets, right? So we have 4 buckets here, index 0 to 3. And then we have at each bucket some other external chain, right? A list with the actual elements in the hash set themselves. And so in this example, the number in parentheses represents our hash code for each string. And we picked some really small, simple numbers for the sake of this example. And so let's say hypothetically, the hash code of Apple is 0. Well, then Apple should go in the 0 bucket. And the hash code of Boots is 3. So Boots should go in the 3 index bucket. But what about Bottom? Bottom's hash code is 4. And there is no index 4 bucket, right? There's no valid index 4 for here. And so what we can do is we can actually find a way to wrap around, right? And make sure that the value 4 falls into this range. And so maybe we've learned about some special mathematical operators that can keep us within some valid range, right? Similarly, if the hash code of jeans is 5, well, there's no 5 bucket. So maybe we want to find a way to have it wrap around. And so it would belong in the 1 bucket if we said, oh, jeans doesn't fit into like any of these indexes with 5, right? But if we were to wrap around, well, then 4 could go back into here and 5 could go back into here, right? So how could we do this? I'm being very vague, but I think you know how to do this. And so I'm now going to sort of walk through essentially a skeleton to ECHashStringSet. But before I do this, I really, really want you to try it on your own. You can ignore me, but I promise you'll get so much more out of this if you pause the video, try to implement this and see where you can go. And then only come back here if you're really stuck. So I'm assuming at this point that if you're watching the video, you have put in your best effort to try and code the ECHashStringSet and maybe you're a little stuck. So we'll sort of go over how to begin setting this class up. Right away, I know that we have some sort of like container of buckets, and then within each bucket, we have a list of the actual items themselves. I know that the buckets actually doesn't really grow dynamically, right? We're never adding 1 bucket. And so this could probably be a plain Java array, because we don't really like add to the end of the array. We're not trying to grow the array dynamically. Rather, when it's necessary, we just double and resize completely. And so that can be a Java array. Whereas these, the lists within the buckets, those grow 1 at a time, right? We're going to be adding a single element and they grow dynamically. So rather than being a Java array, which is fixed length, we actually probably want to make these, let's say, a collection or a list. And so it could be an array list or a linked list. I'll go with linked list because it looks like a linked list, right? Either one works. And so I want to have some sort of array of linked lists, and the syntax is going to be some sort of array, and we'll name it buckets. So the question is, what goes here? Well, if it is of type int, right? If it was an int array, we'd just say this, and we put the type before the brackets. So since I want it to be an array of linked lists, not an array of ints, I'll just put linked list array. And specifically, it's a linked list array that contains strings, right? So I'm putting string in those brackets that specify the type it holds. Now, I have to make some sort of constructor, right? And so let's say I make ECHashStringSet, and I want to say buckets equals new linked list array. And let's say we might want to clean this up later, but I'll say we have some sort of like private int default num buckets, and we can pass that in here, right? And so that makes the size. And there's actually one really annoying thing about the syntax here, which is that if we want to be able to treat buckets and know that within each bucket, the linked list holds strings, we can't just do this. For whatever reason, Java does not like that. And so we have to cast it. And so we're going to do linked list string. This should work. And so now we have our buckets. And the other thing is within each bucket, we've made the outer array, but have we actually instantiated any linked list to go inside? No, we haven't, right? And so if I were to try to like put something into those linked lists, right now, buckets is actually full of null. And so maybe I need to somehow loop through and make sure buckets is actually full of linked lists, right? So that's the first thing we need to do. Now, what about the put method? Well, if I want to put in some new string, what should I do? According to this image, right, if let's say I wanted to put, let's say bottom wasn't already here and I wanted to put it there, well, conceptually, what I do is I compute the hash code for bottom, then I figure out which bucket it should belong in based off its hash code. Once I'm at that bucket, I get the linked list there, and then I append it to that linked list, right? And so we can imagine the flow is something like figure out which bucket to go to, and then maybe we could say we're going to get the linked list at bucket, and let's figure out which index I bucket to go to. Then we're going to get the linked list at buckets of I, right? And then finally, we will add S to that linked list. This seems like a pretty good structure. The only other thing to be careful of is make sure when we're going to add a new element, if we have reached the like resize load limit, right? We should resize. And this is important because if you don't resize, you're not going to pass our timing tests, right? So this seems pretty logical. Now, what about contains? Well, we can imagine it's a pretty similar thing, right? We would first figure out which index I bucket S would be in, right? Then we would get the linked list at that bucket, right? And then we'd have to find out if that linked list contains S. And if it does, we'd return true. And so you're noticing we actually have to do this in both puts and contains, right? Figuring out which bucket a given string should belong in. And so maybe we're going to have some sort of private int, like, let's see, which bucket method, whatever. And it takes in a string S and returns which bucket I the string S should be in. And so within this method, we probably want to call the default string hash code as in s.hashcode, right? But we need to figure out a way to make that default hash code wrap or fit within the range 0 to num buckets -1, right? This all seems pretty reasonable, and I trust that you can do this. And yeah, I think if you were stuck on where to go before, I would just try to figure out how to take this logic and apply it. Keep in mind, resize is probably going to have to be some sort of helper method as well, right? And so within resize, what do we need to do? If we've reached the load limit, well, then we probably need to make a new array, right? To move everything to. Fill that new array with linked lists, right? Like how we did in the constructor. And then we need to take all the elements from the old list or from the like take all the elements from the hash set we already have and figure out which buckets to put them in the new list. And so in the new structure. And so I will leave all this to you. We essentially now have some sort of vague remnants of a skeleton. And yeah, I believe in you. You can do this. Bye.